broadcast is now starting. All attendees are in listen-only mode.
Well, good morning or good afternoon, depending on where you are. My name is Tim Downs. I am your host today for the webinar on answering your questions on enterprise private networking. I represent SmartGig Media, and I'm here to also introduce a new organization that I've formed with my friend and colleague Ian Gillett. Before I get started on that, though, a few housekeeping items. Just note we are recording today's webinar. The recording and the slides will be available in about 24 hours on the IGR website and also the SmartGig Media website. You'll receive an email with full details, so look for that. We'll be taking questions today, so please use the questions tab on the GoToWebinar control panel. And given the amount of time we have, 45 minutes, we should get to at least several of your questions this morning. With that, I'd like to introduce my partner, Ian Gillett. Ian is the founder and president of IGR. Many of you know IGR for the market research work they have done in the wireless and mobile industry. I've known Ian for more than we both care to admit, couple decades. We've both been in the wireless industry for a long time. And part of the reason that we have elected to create a new organization is just that. We've been in the industry for a long time, and we see very exciting, massive disruption coming. And a lot of it has to do with CBRS, on-go, and what it enables in the enterprise. And we don't see too many other companies and any other firms that have really focused on what CBRS means for the enterprise, can do for the enterprise, and the innovation that will come from CBRS and the enterprise. And so we decided to launch a company working together to try and help our industry introduce all these various innovation and technology and thought leadership to the enterprise community. And that's what the 2030 project is. We're giving it 10 years. That's our 2030 project. And we think between now and 2030, we will, along with our friends and colleagues, partners, sponsors, advertisers, and supporters, will open up and bring on a whole new day in the wireless industry. We very much look forward to it. We think it will be far more disruptive than the first dozen years that we were both in the industry. So that is the 2030 project. Feel free to email us if we can answer any questions on that or anything else we're up to other than CBRS, but this webinar is focused directly on enterprise private networking, how LTE, CBRS, 5G, and edge compute all conspire to drive innovation in the enterprise. With that, I'm going to toss our first question that we've received from the audience to Ian. So Ian, kindly explain to us what the difference between private LTE and Wi-Fi is.
Great, thanks Tim, and good afternoon, good morning everybody. As Tim said in preparation for this, when you guys registered, you did put in your questions. This is actually one of the most common ones we get, and we still get. I think there's a lot of confusion, especially with Wi-Fi 6. People, there's a lot of capabilities within Wi-Fi 6 that look a lot like LTE and look very cellular, if you like. So I kind of laid everything out here, but basically the way to think about it is private LTE or private networking is going to use licensed or unlicensed spectrum. CBRS we'll talk about is a little bit later, it's kind of lightly licensed. If you were putting in a private network in Europe or Asia, then if you want to use private LTE, you're going to have to go to an operator and get some spectrum. Wi-Fi, of course, uses unlicensed spectrum, 2.4 gig and 5 gig bands, and soon to be the 6 gig band. The private LTE uses the same protocols as the public LTE networks put in. So when AT&T, Verizon, T-Mobile deploy LTE, it's the same LTE you can put into a private LTE network. There's no difference. The equipment's a little different. It's simplified down a little bit because you don't have some of the management requirements you do in a big network. And private LTE, of course, is upgradable to 5G, which is another question. We'll have a little bit more detail on that in a second. There's extensive security within LTE. The Evolved Packet Core is the back end of LTE, and there's extensive policy and device management in there. Your device, your phone, has what's called a SIM card or eSIM as well, and your phone has to authenticate onto the network and gain access. You don't have to log in or anything like that. Wi-Fi, of course, is a little different. There's a wide range of devices there. It is deployable by consumers, small business, enterprise, obviously. But there are various levels of security. So if you think about just about when you put Wi-Fi in at home, it gives you a choice of WPA, WPA2, et cetera, but there's really not much device and policy management. So if you walk into, let's say, Starbucks or a retail store and you want to use their Wi-Fi, usually you have to log in, right? It may be, and a lot of times, I'm just thinking of the airport, the lounges, you see those little signs say, log in, here's the login and then the password. With LTE, there is none of that. Your device is either allowed in or it's not, according to the policies set up by the network manager. So, for example, if you had a private LTE network in a commercial real estate, in a large office building, the building could say, okay, all of the employees here will let their phones in, but any guests don't get access to that network, for example. Private LTE as well. LTE has good spectrum management, traffic priority, very scalable. It's designed to run big networks. Wi-Fi, of course, is not. It's kind of a first comes, first served resource. And of course, you can see that sometimes it gets congested. You can see that when a network is being overloaded. LTE's got a good device ecosystem. It is getting bigger. It does tend to focus around tablets, smartphones, the things that we use on the big networks, obviously. But there are also cameras and IoT devices and things like this. And there is a developing network ecosystem. CBRS is unique right now to the US, and we'll talk about that in a second. But we are developing this network ecosystem from different vendors, different solutions. Wi-Fi, of course, has got a very big ecosystem. You can go onto Amazon, go to Best Buy, and get whatever you need. So the differences between the two, they're using similar spectrum. They've got similar throughput capabilities. It really comes down to the amount of management, security, policy enforcement you want. LTE, in my mind, still is ahead in that game compared to Wi-Fi and Wi-Fi 6. Okay?
Very good. All right, that leads to our second question, which is, and this does often come up in our various events and webinars, et cetera. What is CBRS and how does it relate to private LTE and 5G? And maybe along that line, you can explain exactly where the term private LTE comes from and what it really means.
Yeah, so CBRS is interesting. As I said, it is unique to the US. The world, is deploying private LTE networks, obviously 5G. CBRS is something the US did. The work started on it quite some time ago. I think around 2015. So what they've done is take this 3.5 gigahertz band. There's 150 megahertz of spectrum there, and I'll show you a picture of it in a minute. But it's lightly licensed. You can use it, just go by device and use it, or there's going to be some what they call the PAL auctions, priority access auctions, in July, so you can buy some dedicated access to it. But it's a shared spectrum resource, so there are incumbents in there as well I'll talk about. The CBRS Alliance, which is the ecosystem of all the vendors, they've branded it as OnGo. So if you see the name OnGo, that is referring to the CBRS band as well. It does use LTE equipment, and it's, as I said, it's the same LTE equipment you would get in a macro network from used by one of the big carriers, for example. And CBRS, it can be upgraded to 5G when ready. There is a path towards that, and I'll talk about that in a second. So this is the technical slide of the CBRS band. As I said, it runs in the 3.5 gig band. It actually runs from 3550 megahertz all the way up to 37 above 3700 there. And you can see that there's this in the middle there. There's that kind of greenish color, 70 megahertz for the PAL auctions. So there's 10 of those. The auctions of that's going to be later in the summer, in July. Actually, they start. And then there's this GAA, the general access user, which is the orange on the bottom. Now there's 150 megahertz there, so it's 150 megahertz for everybody to use. If all 70 megahertz of the PALs are used by their license holders, they take priority over the general access. So general access gets cut down to 80 megahertz, but that wouldn't happen all the time. It's only when all of the PALs are being used. So if a PAL is not used, the spectrum is available to everybody. And this is where this shared spectrum term comes from. Now, it's important here, there's also the dynamic shared spectrum DSS that we get in the big macro networks. That's more of a technical solution within a macro network to share different parts of the licensed spectrum. So it's not the same as the CBRS shared spectrum. They use the term shared, but they're using it in different ways. And then finally, I'll just point to that the federal use at the top. This band was actually in use by the Navy and the Coast Guard. It's actually used to land planes on aircraft carriers. They still have the rights to use that. So if there's interference there, the Navy gets priority. And the system actually, we'll talk about this later on, but the system actually manages that process and manages that interference to make sure everybody's happy. Okay. One final thing, and this is important, it gets a little techie on here, but there are actually 3 categories of what we call a CBSD. So the CBSD is the radio, it's the node, it's the equivalent to the access point in Wi-Fi. You would put CBSDs around your building to get service, or around a downtown area or whatever to get service. Category A is limited on the power, and it's really for indoor installations. And so you could put a Category A CBSD into your building, into an office building, a warehouse, or whatever, and provide coverage. And we'll talk about use cases in a second. The Category B is the outdoor, and it's actually split rural and non-rural. And the difference is purely power. So Category B non-rural is for outdoor, downtown, urban installations. It's professional install, so it would be an operator have to do it or somebody else. But then Category B is for rural, and the power on that is actually pretty good. So this one you could see, for example, if you had a farm, you could put a Category B rural radio up on the, like a grain silo in the middle of a farm, and have service all over the farm for different applications. And so the propagation is going to be pretty good. The power output, you can see there, it's negative 30 dBm. It's pretty good. And again, in a farm, you're unlikely to have conflicts with the Navy or anything like this. So you could have 150 megahertz of spectrum. Okay.
Great. All right. One of the most popular questions we get is on private networking, Ian. Why would an enterprise deploy a private network? What is the use case for it? Or in another question, what are the top use cases?
Yeah, you and I have talked about this a lot. I spent a lot of time talking about this. And actually, we had some questions before we got started today. And one of those questions was, what do I do with this? And it's a common question. And I think, the answer is, as I said on the first part of the slide here, there's lots of things you can do with this. but there are very specific industry specific applications. And it's important that healthcare is going to have a very different need, for example, from hospitality or retail or warehousing or whatever. I think the important to think about is, I don't think any enterprise has ever said, let's put in a new network. What they do is they say, hey, I've got this problem. I can't connect to my workers, users over here, or I need to put security cameras around a building and I don't want to, or I can't pull wires to them to connect them. So I want a solution that allows me to put up a video camera and have a wireless secured connection to that video camera at all times. Or I need a network that's going to allow me to connect this application for these, for these employees out in this part of the warehouse or something like that. So it's always application and use driven, and that leads to CBRS or the private network becoming part of that solution. Now, once the network's in, we can layer more stuff on top of it, right? We can do more things with it. So once you put it in for the security cameras, then it's like, well, heck, we could have secure access on every door now using the same network, things like this. Smart city, smart grid is another popular one we hear a lot about. We're actually involved in a project that will start later in the year, which actually is using private networking, actually around 5G for that. The other one that's come out is push to talk, which is really interesting. Those mission critical push to talk. So this is the old Nextel, right? But now putting those systems on a voice over IP using LTE, secured, etc., etc. That one's actually come back as a very popular application. Manufacturing, we hear a lot about. It could be IoT within the manufacturing facility. It could be autonomous vehicles and robots running around. Education is a popular one again. There's been a lot of discussions because with private LTE, private networking, I can keep the traffic just within the school. And obviously I can have it secured so that only the kids and teachers can get on the network. They don't have access to the bigger internet, things like this. And as we go through this, you're going to talk more about edge computing. We see that a lot being combined with private networking because you keep the processing, the storage, and all that communication in a controlled, managed environment. So with private networking, you could have a network that is not open to the rest of the internet or the world. All the applications sit there, they're firewalled off, and they're controlled. Now, I've got a picture here, and I've used this before, but this is kind of how we see the world in a few years' time. And you can see, if we just look around, you can see different applications on, bottom left there, manufacturing and transportation, for example. The commercial space above that. The interesting thing is, and all of this is a 5G world. A lot of it we can do, of course, with LTE as well. But if you think about the red circles here that I just added, those could be private networks using private LTE or private 5G within those buildings or those environments. So it could be within the stadium, within the manufacturing plant. The stadium is a really good example, actually, and a lot of this comes back to the difference between Wi-Fi and private LTE. The stadiums have already put in CBRX, and one of the most popular things to do is actually have it for point of sale and credit cards, because the point of sale merchants within the stadium are all using the same Wi-Fi network as the audience, and as the audience takes photos and uploads videos and things, the network gets swamped, and there have actually been instances where they can't get the point of sale transactions through. So they've put up a CBRS network, it's secured, it's manageable, etc., etc. And so the credit card transactions go through more quickly, means that shorter lines at concessions, therefore you can get more people through the concessions. It's a very interesting use case that shows an increase in revenue just by able to do point of sale more quickly. But obviously, there's lots of other applications as well. We could spend all the time going through the different ones, but you'll see the list on here. Smart utilities are very popular, smart building, security, maintenance, drone control, autonomous vehicles around manufacturing, for example. There's lots of different applications.
Well, and the different applications lead to different advantages. Here you go.
Yeah.
So why don't you discuss those?
Yeah. Advantages, disadvantages. Well, the first one is on the advantages side. If I'm using CBRS, I don't have to go and get any spectrum from an operator. Again, if I'm in Europe or Asia, I'm going to have to do that. But to be fair, the operators, certainly Deutsche Telekom, Vodafone, have been very, very open to having private networks use their spectrum. I think Vodafone was opening up 10 megahertz of spectrum, 4 or 5 years ago to enable this type of thing. In the US, as I said, we do have CBRS. Canada is about a year behind us getting CBRS. They're looking at a similar plan. But the other thing is, you're on the roadmap for upgrades. So as the big macro networks upgrade from release 13 through 14, then to release 15, which is 5G, then 16 and 17, your private network equipment is going to do the same thing. You're in the same ecosystem. The equipment also, you can leverage virtualization, SDN, edge compute, and the same type of thing. You can run this all from the cloud, and I've actually got a picture later on of what the network looks like. This is all enabled by cloud and hosted solutions. As we said, we've got the security and management in there. We already talked about that. It's also mobile because this is a cellular network. If you choose to enable mobility, then it'll support that. So, for example, if you've got two warehouses, different parts of town, let's say, and you have employees who go between the two of them, then they could use their private network device in each location without problem if you so allow them to. Again, you can restrict that as well. It's not like having two Wi-Fi networks where I have to log into each one, for example. Predictable RF environment. The final one is very important. We can make this interoperate with a mobile operator's network. So if you choose, you could come off of the AT&T network, walk into a building, and have that connection or that call hand off to the private LTE CBRS network in that building. You may choose not to do that. You want a walled environment. You can do that as well. But you can do the interoperation there, and there's a couple of companies who do that. Cineverse enables that. Geoverse does that as well. It's quite an interesting approach. Disadvantages: not a lot of enterprises have LTE expertise in house. This is relatively specialized stuff. I think enterprises are pretty good at IP networks, certainly Wi-Fi. So you are going to have to rely on an integrator or another third party to install this, manage it, maintain it, etc. And that could shift from CapEx to OpEx. You can actually get solutions now where you lease a CBRS network. You never actually own anything as the enterprise. You just lease access to it. Again, you can have a little bit of a re-architecting of the operations here. LTE is based on IP. It's just mobile IP. So integrating an application really shouldn't be a problem. But you do start to think about when you get into edge compute and cloud compute trends now you start rethinking about where you're actually going to do the processing. So it's not just a case of, hey, let's put in a private network. It's right a case of where do I want this compute, where do I want this data to be processed? And it can become part of a bigger overall effort. I put the last one is LTE is old. It's actually about 10 years old, but private LTE is new, and a lot of people get confused by this. If you're implementing now, you are relatively on the cutting edge here. The first network for CBRS started going in late 18, more in 19 in trial form. Now CBRS is commercial, and there's more going in. But you know, if you're putting in something today, you're going to be a little bit on the front end of things. There may be some trial and error involved, certainly compared to something like Wi-Fi, which is pretty much a known entity, right?
Yep. All right. Well, so 5G is the shape of things to come, as we all know. Tell me what it means for an enterprise to deploy private LTE, and then how does that either integrate or translate, or what is the roadmap between a private LTE in an enterprise and a 5G environment that will be deployed either by a carrier or a new entrant, et cetera?
Yep. Yeah, and again, this is a very common question, and actually, I remember you and I, Tim, were talking last week, and you made the comment that a lot of people think 5G is just related to the big operators, Vodafone and China Mobile and AT&T, Verizon, etc. A lot of people are surprised when they find out that you can actually build a private 5G network. So the first answer is, if I deploy private LTE, can I upgrade it? Absolutely yes. In February, the CBRS Alliance announced a new technical specification that basically takes the 5G definitions, and 5G is defined as release 15 of the 3GPP, by the way, and incorporated incorporated release 15 into the standards for CBRS. So once that equipment becomes available, you will be able to deploy a release 15 network using the CBRS band. Now, because of the way the infrastructure works, it's likely that those new CBSDs, those new radio access points you're putting in today, they'll be upgradable to 5G. If you put in in the big macro network, if you put in a radio in the last couple of years, it's software upgradable to 5G today. There may be some other things on the back end you've got to do. For CBRS, you will need a 5G core. There are upgraded capabilities in that core from what we have as an evolved packet core, the EPC in LTE. But you can host that in the cloud. So let the hosting vendor deal with that. You don't have to deploy that in your premises, on site, unless you want to really lock things down. You can also put in the license band as well. It's the same public 5G networks. Now, the other point with this is a lot of the 5G networks are using millimeter wave spectrum. So these higher bands of spectrum, the FCC has had auctions, other countries around the world have had auctions for 24 gig, 28 gig, 39 gig, et cetera, et cetera. So one of the common questions we get is, well, can I use those bands for private 5G? And the answer is yes, if the operator allows it. So one of the great applications for this is in manufacturing, and the ability to connect very sophisticated machine tools. Today they'll have a fiber connection. It's very expensive to move those tools, and a lot of it is because you have to move the fiber in the building. Having a wireless connection using millimeter wave means you can move the tools or reconfigure the production line without worrying about the communications links. But 5G is high bandwidth, it's very low latency, which is great for machine tools or robotics, autonomous vehicles within the manufacturing plant. So for something like this, you'd go work with, as I said, Vodafone, Deutsche Telekom, Optus, Telus, Bell Mobility, ATT, Verizon, etc. And actually, a lot of the German people like Bosch, very involved in this, actually have got partnerships with the operators to enable that. So absolutely, there's a path. And I think if you're putting in private LTE today with CBRS, don't worry that you're locking yourself into something that's already outdated. No, there's a path forward that is very well defined and quite straightforward. Okay.
All right. Well, that leads to one of the other common questions you and I have heard over the years, and that is, how does a private LTE network compete or integrate with a public cellular network offering, such as one from Verizon or T-Mobile?
Yeah, and this is a good one. Actually, this question, I copied it verbatim from something that a couple of people typed in, actually. Um, do I have to have an operator involved is a common question. The answer, of course, is no, if you have access to CBRS. Do I need an operator? Well, you may want to. We'll talk about that in a second. But the other thing is, is CBRS here, is private LTE, going to take away business from the big operators? And it could. It's interesting when you look around the world, some operators wholly embrace private LTE, private networking, and want to be involved and want to help. Others are a little bit more standoffish and thinking it's more competitive and maybe I need to take my own path for this. But if you want an operator involved, the good news is, you get access, as I said, that millimeter wave spectrum. You can get roaming to nationwide networks. So if you're somebody like a warehouse, for example, you've got the 18-wheeler truck coming in. Obviously, it's going to be on the macro network, on the big network. As it gets into the warehouse, it could flip over to a private network. But having integration between the two would be very important. I think for a lot of commercial real estate, as we said, that's important as well. There's also, we do have to have the number and SIM card coordination as well. The carriers are very good at that. Other vendors can do that for you as well. Cineverse actually does that for you as well if you want to be as an enterprise. And operators have got access to a lot of devices. There's a lot of things they've got access to, and obviously AT&T buys way more iPhones or more Android devices than any enterprise does. And also integration with the wide area IoT networks. All the big operators have got IoT offerings and product. You could have that. There are other MVNOs like Sierra Wireless, for example, as well. So if you're a farmer, let's say, you may want a private CBRS network around your farm, but maybe you've got a farm that's a couple of miles away. You want to integrate those few devices over there into your network, things like that. The negatives, commercial real estate especially, and enterprise, there's a little bit of a fear of committing to one mobile operator. So if I let AT&T in, can I get a Verizon in? If I do a deal with T-Mobile, can I get the other two in as well? And frankly, in Europe, the operators work together a lot more closely than the US operators do. We have a much more antagonistic competitive environment here between the three operators. We don't see a lot of coordination or cooperation between them. If you're a big enterprise who needs that cooperation, that can be a problem. Some of them can be slow to deploy. I said signal source for DAS here. The in-building distributed antenna systems we've had for a while, the hardest thing to do with that entire deployment is not putting in the radios or pulling the fiber or pulling the coax. It's actually getting a connection to the operator networks. And any vendors, DAS vendors online right now are probably nodding their head, like, yeah. And you're also reliant on telecom versus IT standards. I think that can, operators obviously have very big networks. They have to be very careful what they deploy. Whereas an enterprise has got a smaller consideration, if you like. And then the deeper in the organization you get, the harder it gets to do. It's this, not in my backyard kind of approach. We have seen with some of the operators, we saw this in the early days of some of the edge compute stuff, where the operators at an executive level said, yes, we're going to make this happen. At the lower levels, like, no, I'm worried about security, my P&L, those types of things. Along the bottom, I've got some other things that come out. We hear about the hyperscalers are moving very quickly. The Amazon Web Services, Google's clouds, etc. They are offering solutions, starting to integrate with these things. The private network solution is more than just a network. AT&T can't really help you integrate your application. Verizon isn't going to have the edge compute hardware you'd need. So really it is a systems integrator with a network component, with an application, with some hardware, compute hardware, with a cloud environment, all integrated together. It's not just one piece. Oh, we've got private LTE, all our problems are solved. That's not really the answer here. And the next one on the bottom there, this perceived value for the enterprise is the application, not the radio. It's very important. We hear about this a lot. The enterprise wants a solution and an application. A radio vendor wants to sell you a network and a radio. And the radio isn't the answer. It's the integrated solution is the answer. And I think that's a very important difference between the operator approach and the enterprise approach. And enterprises have their own vendors, right? Their go-to vendor may not be AT&T or Verizon or T-Mobile or Vodafone. It may be Dell or IBM or KPMG, whoever it is, right? So it's an interesting, I think there's a lot of cooperation opportunities here. I think we will see some interesting solutions. But certainly, could this take away from the operators? Yes, but depending on that level of interconnection you want, and that varies by application, then the operators are still going to be around.
Well, before I jump into the next slide, I will do a little plug for you, Ian. You did a great 10 minutes interview with the founder of a company called FreedomFi, and that interview is on the Private LTE for Enterprise website. And it is all about the application value, as you just spoke about, the application value that the computing and cloud guys see as the value for CBRS. So look for that. So before I jump into this slide, I'd also like to just remind you that if you do have questions, use the question tab on the GoToWebinar control panel. We're up to about 20 questions now. We'll try and field as many as we can. But we're switching gears a little bit here and talking about edge compute and how the march towards the edge of the network in computing and in architecture fits into the private networking scheme. So maybe you can talk a little bit about that too, Ian.
Yeah, and this is, I put these questions, again, this is a question we had a couple of times from people when they registered for the webinar. I did put these in order to try and kind of build on the story here. Because this is really how the cloud folks view this opportunity. So an edge compute server is just what it says. It's a compute resource that sits right at the edge of the network, as closest to the user as you need it to be or you can get it. You get improved response, lower latency. You're not sending all the traffic and all the content up to the cloud to be processed and sent back. You can reduce backhaul costs, things like this. And the other thing is everyone thinks edge is only for private LTE or private 5G. No, actually the first applications for edge compute were deployed 3 or 4 years ago and actually use Wi-Fi and Ethernet. So it really, edge compute doesn't care what the wireless connection is. My little picture here is, imagine this is the enterprise here in purple, and it's got there's 2 locations. We've got a private LTE network with Wi-Fi at the same location. We've got private 5G with private LTE at the other location. So maybe that top location is something in the retail. Maybe the bottom one is some sort of warehousing, for example. We could put edge compute in both locations, connect the 2. My little dots here represent the different applications that can run. So we can have maybe that top location is on one side of the town and the bottom location is on the other side of town, or a different city or state or whatever. But both edge environments are linked. The users would enjoy the same access and the same applications in each location. But notice there's no connection here to the outside world. Everything is completely contained. We see this a lot with manufacturing, high-value manufacturing, defense contractors, defense manufacturers, obviously have a lot of sensitive equipment and information in those buildings and want to keep it in there. The next kind of build on this is you say, okay, well, I want to connect to the public cloud. And if you look, I've got a blue dot in the public cloud that's also in my edge compute here as well. And so I've got an application here that's running locally on the edge compute, but it's also running up in the public cloud. Maybe the storage into the cloud and the imaging or something that's very latency sensitive is down on the edge. Notice the yellow and the red, they're not in the public cloud. So they're applications that are staying local. And also there's a purple dot in the public cloud that's not on the edge. So that purple application only runs in the public cloud. So you can have apps running in different places. They can run only in the cloud, only on the edge, in both. They can go backwards and forwards. But this, this obviously not an unusual type deployment here. If we've got something like Amazon Web Services up in the cloud there, plenty of customers use them, or Microsoft, Google, et cetera, et cetera. But you can have Edge as an extension of the cloud. A great example of this actually is for things like augmented reality, certainly in manufacturing and things like this, where image processing is very latency sensitive. It's very compute sensitive. It's a resource, a hog. If I'm sending all those images up to the cloud to be processed and sent them back, that's going to use a lot of bandwidth, and it's going to add a lot of latency to the application. You do all the imaging locally, so that the user doesn't feel that delay, that lag that can cause problems. And that's a good example of edge compute and the cloud working together. Now, my final one is, now let's bring the operator back into this. So now I've got my enterprise over here. Let's say it is a warehousing logistics distribution company, and they've got trucking as well. The trucks are going to be on the operator network. Could be using LTE or 5G. The operators are putting in edge compute as well. Verizon has a deal with Amazon Web Services. I think AT&T works with, Google. But we've just seen Microsoft buy Affirmed Networks. Affirmed actually make the LTE EPC, the packet core. And so Microsoft taking that and operating in a public cloud type environment is very interesting. So we can have the operator environment here linked to the enterprise environment. We've got applications running in all these different places, as you can see. But again, notice that red dot. That red dot is only in the enterprise. It is not being run in the cloud or the operator network. So we've kept it kind of secure. So again, one of the problems we have with edge compute is saying, well, what do I do with it? And the answer is whatever you want. It's massively flexible, it's massively scalable, and these three diagrams just show we can go from a very simple application, very simple implementation, to something like this, which obviously is a lot more complex and involves a lot more resources. Okay.
So why don't you? Yeah. So after your discussion on Edge, why don't you go back a little bit and just recap what are the components of a private LTE network from top to bottom?
Yeah, so I put this one last because it's a question we get a lot again, so the happy smiling faces on the left there, they're the users. It could be obviously a person, it could be an IoT device, it could be a moisture sensor in a soybean field. A variety. It could be a sensor on a refrigerated truck, for example. The CBSDs, as I said, are the radios that, and this is a CBRS example we're showing here. So these are my CBRS radios. And the green connection is through, you see that SAS there. The SAS is a database that actually coordinates all of those CBRS radios. And there are 4 approved SAS vendors right now, Google, CommScope, Federated Wireless, and Amdocs. Amdocs actually was authorized last week. They had a big announcement about it. And you remember I said that we had the Navy involved and we have to coordinate interference with the Navy and things like this. Well, there are also microwave vendors, wireless ISPs, I should say, who use the 3.5 gigahertz band as well. So the FCC keeps a database of those of commercial users who already have a license. That environmental sensing capability is to check for interference. So if the CBSD connects to the SAS, one of the SASs, they all coordinate between them to make sure that we're not interfering with the Navy or with the wireless ISPs or other people. And the SAS will actually tell a radio, it can tell a radio to change channel or power down for a few seconds to remove or mitigate that interference, okay? Now, when you buy a CBSD, some of the vendors actually are including access to the SAS with it. There's actually a subscription where you can buy access to the SAS for a few bucks a month type thing. Other vendors are offering a hosted packet core, the LTE EPC, which is the red box on the bottom. They're offering that as a hosted service with the SAS service, all in one bundle, together with SIM provisioning and things like this. So the red line is actually where your traffic goes. The green is just the control for the SAS. So if you've got a smartphone on a CBSD, your access to, let's say, the internet is going to go down through the LTE EPC and out to the cloud there. And we talked about what the EPC does. That has all the security, policy, enforcement, et cetera, et cetera. But you do need access to an EPC for this. But again, don't think as an enterprise you have to go out and buy an EPC platform, deploy it on hardware, build yourself a mini AT&T, Verizon, T-Mobile network. No, you can just access this. It's hosted. You can just literally connect up your CBRS radios and treat it as OpEx. One of the questions we get a lot, and I think it already came in today actually, is what's the cost of deploying? How much does it cost to actually deploy this type of network? And the answer is the CBSD radios. The pricing is out there, but a couple of $1,000s for a pretty good one, and that price will come down as we get more vendors in the ecosystem. And compare that to a commercial Wi-Fi access point being $1,000 or so. Don't think of it as comparable to a home Wi-Fi access point, which is obviously on the lower price point. And then you do need access to the SAS and the EPC, and again, dollars per month is the type of number you need to think about. Again, the pricing is out there. Different vendors have different pricing, different packages, but it's not prohibitive. And don't think of it as when you see like T-Mobile or Dish Network saying, hey, we're going to build a 5G network, it's going to cost us $10 billion. Not the same as what we're talking about here. They talk about a nationwide network, same equipment, but this is a different price point, a different level of scale. Okay.
All right. Well, that covers all of your slides. I think we have time for at least one question. Do you agree?
Yeah, we've got a couple here. Yep.
Yeah. You want to go through them, or you want me to ask the one that I think is interesting?
No, you ask the one that you think is interesting. Let's see if we agree.
Yeah. So, question came in: How does the CBRS approach compare to DSS technology? And I presume that's dynamic shared spectrum or dynamic spectrum sharing technology. I think that leads into your last slide, anyway.
Yeah, it does. And again, it's the use of that word shared, right? That's what throws everybody off on this. So CBRS is a shared spectrum band in that you can, as I said, in July, you'll be able to buy a priority access license, and you're sharing that as a priority user with general access. And if I don't need my PAL at a certain time, my spectrum or that piece of spectrum goes back to general use. It's sharing amongst a bigger population until the priority access user wants it. DSS is what the big public networks, so the Ericsson's made a lot of announcements about this. And I think they had one the other day, actually, of another operator putting in DSS into their public network. And what that does is it actually shares spectrum between the licensed bands that the operator has. So if an operator's got, let's say, 700 megahertz and 1.9 and 2.1 gigahertz, those types of bands, it'll actually share those spectrum bands within a connection, within a call, to maximize the use of that spectrum. As a user, you never see it. You'll never know. Your phone will deal with it. The network deals with it. It's all to do with the coordination of the spectrum within that. But it's not really something that an enterprise is going to say, gosh, I need DSS. If DSS were built into the CBRS radios, you'd never know about it and you wouldn't worry about it. CBRS is based on LTE, as we said. LTE uses OFDMA, orthogonal frequency multiple duplex access, I think it is. I may have got that wrong, but it's definitely orthogonal. But there's a lot of very, very technical stuff, complicated stuff that's in there that you just do not see as the user. And DSS is kind of one of those things. So, okay.
Okay, great. You want to answer one more?
Yeah, actually, the other one is there's a question. Actually, there's two questions about the Linux Foundation with Chord and also Open RAN and how they relate to what we've been talking about. And I think it's worth touching on that. You mentioned, Tim, earlier about the interview we did with Boris Rensky from FreedomFi. Boris is an open source software guy. He looks at the wireless world and says it should be more open. I'm going to write software that's open source for the packet core and the radio and things. The Open RAN movement with the ORAN Alliance and other groups are actually building open networks where the interfaces between all the different components are published. The goal being to reduce the cost of network deployment. Within Open RAN, there's I think it's called Evenstar, I may have got the name wrong, but it's a project to actually get $1,000 5G radio to market, which we'll probably see later this year, which is very inexpensive. That will certainly help all the things we're talking about here today. And then CHORD is, I love this acronym, it's Central Office re-architected as a data center. So again, it's taking all the EPC, the back-end operations, and saying, you know what, it's not so much a telco network, let's make it look more like a data center network and data center operations. So when I said that you can host an EPC and you could get access to a hosted EPC from a variety of vendors, they've actually taken that approach with and said, look, let's deploy it in a data center, open up access through the cloud, and it's the same type of concept. CHORD is a little bit more specific to mobile operators, but same idea. So, okay.
Very good, very good. Well, we're at 55 minutes. I think we've covered a lot of ground. I appreciate it, Ian. To the audience, thank you for joining us today. We hope you found this time valuable. Again, we're recording today's webinar. The recording and the slides will be available on in about 24 hours on the IGR website, as well as the private LTE for enterprise.com website. Both our contact information is on each website, and feel free to contact us. We'd love to see you at one of our private LTE for enterprise events or webinars that we have scheduled throughout the summer and the fall. Thanks, everybody, and thank you, Ian. Great job. Goodbye.
Great. Thanks, Tim. Thank you.